Zeer-Pot cooler. Two unglazed terracotta pots, one nested inside the other, the gap packed with wet sand. No compressor, no refrigerant, no grid dependency. Internal temperature consistently running 15 to 20 degrees Celsius below ambient air, even when ambient is pushing 40. That's not a rough estimate. That's the documented delta T from field deployments across the Sahel and North Africa, where this technology has been keeping perishables viable since before indoor refrigeration was a concept anyone's grandfather had heard of. Here's the thermodynamics. When water in the sand layer evaporates, it pulls latent heat directly from the inner pot. Latent heat extraction is the same principle your body uses when you sweat, except this system doesn't stop working when the power goes out. Rate of cooling depends on two variables: air relative humidity and airflow. Dry air performs better. Under a shaded balcony overhang or an open window on the windward side of your building, you're looking at consistent sub-20 degrees C internal temps for leafy greens, root vegetables, and cooked protein stored in sealed containers. The wetting schedule every 12 hours or whenever the sand surface feels dry to the touch. 1 cup of water per cycle poured slowly over the sand. 5 centimeters of gap between pots, filled with coarse damp sand as thermal buffer. If you drop the outer pot, you spend $3 on a replacement. Try that with a compressor unit. Fruit and vegetable shelf life in a properly maintained Zeer-Pot runs 2 to 3 times longer than open-air storage under identical conditions. For the 72-hour to 10-day disruption window, where the overwhelming majority of urban grid failures concentrate, this eliminates your fresh food spoilage problem entirely. The grid doesn't get a vote in this equation. Moisture does. You control moisture. If you're setting this up on a balcony, the next piece of hardware makes the whole system significantly harder to compromise from outside. The balcony pulley rig. A single sheave pulley, a stainless steel carabiner rated to at least 100 kilograms, 10 meters of marine-grade 8mm braided polyester rope, and a galvanized steel mesh basket. Total outlay: under $5 at a hardware or marine supply outlet. This configuration, repurposed from maritime cargo handling, carries a working load limit that exceeds anything you'll put in it, with abrasion resistance that holds up against building concrete edges and metal railings over years of daily use. The mechanical advantage of a basic single-sheave pulley reduces the effective felt weight of a fully loaded basket by roughly half. A 10-kilogram food load becomes a 5-kilogram pull. That matters at 2 in the morning when you're operating in low light and don't want to make noise. External balcony stowage accomplishes 2 things that indoor storage cannot replicate. First, distance buffer. Food stored outside the living envelope doesn't contribute to indoor humidity, odor, or pest attraction. Second, concealment. A basket hanging below balcony level from a rope is not visible from the street, is not accessible without equipment and direct line of sight to your specific floor, and produces no thermal or scent signature. In a disruption scenario where the social environment degrades before the infrastructure recovers, the distinction between visible supply and invisible supply is not abstract. It's the operational gap between being a target and not being one. If you found this useful, the light keeps this content visible to people who actually need it, hardened and ready. The pulley rig solves the external exposure problem. What goes inside the basket determines how long your system actually runs. That's where chemistry takes over from physics. Mylar pouch sealing protocol. Get the sizing right first. A 1-quart pouch handles approximately 500 grams of dry rice or lentils. A 1-gallon pouch handles up to 3.5 kilograms. Overpacking degrades the seal. Maintain a minimum 4 centimeter clearance at the top before sealing. Insert 1 300 cubic centimeter oxygen absorber per quart, or 1 2,000 cubic centimeter absorber per gallon before you close the bag. Don't leave absorbers open to ambient air for more than 20 minutes. They begin consuming atmospheric oxygen immediately and lose efficacy inside that window. The sealing process. Press the bag flat to reduce headspace, then run a household iron set to medium heat, no steam, along the top 2 centimeters in a single continuous pass. A properly sealed Mylar pouch resists finger pressure puncture and shows 0 outgassing at the seam after 30 seconds. The mechanism: aerobic bacteria and fungi require oxygen concentration above 0.5% to reproduce. A correctly placed oxygen absorber drives internal atmospheric oxygen below 0.1% within 4 hours of sealing. At that point, aerobic spoilage is no longer a variable. Oxidative rancidity, the chemical degradation that turns whole grains bitter and oily, also ceases. Properly dried rice, hard wheat, legumes, and powdered milk sealed this way shift from months to years of shelf stability. This protocol comes directly from institutional emergency food logistics and military field ration storage. The same methodology, adapted to a kitchen iron and $5 of materials. The full sourcing list is in the description. If you're not subscribed yet, this is the correct moment. The remaining systems in this sequence build on each other, and reconstructing the chain from memory is not a reliable fallback. The intel you need before the grid forces the issue is already on this channel. Subscribe and keep access to the feed. The next failure point is the one that trips up everyone who seals their food correctly but stores it wrong. Ventilated steel cage. Most people seal their Mylar pouches correctly, put them in an airtight plastic tub, and find mold within a week. The physics of high-rise microclimates are working against them. A sealed container in contact with exterior concrete walls accumulates condensation on its interior surfaces every time the temperature delta between ambient air and container wall crosses the local dew point. That happens most nights in temperate climates. And condensation inside an airtight bin produces exactly the anaerobic high-humidity environment mold colonies need. The counter protocol: 18-gauge galvanized steel mesh. Aperture between 3 and 6 millimeters, bent and fastened into a rigid open frame. This geometry comes from apiary and industrial food rack design, built for passive airflow through perishable stock. Ventilation keeps relative humidity inside the storage zone below the threshold fungal growth requires. The mesh aperture physically blocks any rodent species capable of biting through Mylar. Galvanized steel does not trap heat the way plastic does and does not off-gas under prolonged sun exposure. Stay invisible. The mesh cage attached to your pulley rig, hanging below the balcony railing in shade with airflow. That is a system that disappears. No thermal signature, no visual indicator at street level, no scent plume traveling into the corridor. The physics of the solution are simultaneously the physics of the concealment. Solar dehydration and fermentation stack. 2 preservation processes, 1 protocol, 0 power. The dehydration component uses stacked passive draft solar trays, aluminum mesh frames inside a black painted enclosure with a front glass panel that concentrates solar thermal gain. The design draws directly from indigenous sun-drying practices documented across sub-Saharan Africa, the American Southwest and Central Asia, adapted into a compact format sized for a single balcony section. The mechanism is water activity reduction. When the internal water content of a food drops below 0.85 on the activity scale, aerobic bacterial growth ceases. Below 0.70, mold growth ceases. Meat jerky properly dehydrated to below 10% moisture content reaches shelf stability without refrigeration for 60 to 90 days. Root vegetables and herbs processed the same way extend to 6 to 12 months. Caloric density also increases, useful when storage volume is a hard constraint. The fermentation component uses food-grade stoneware crocks with water seal airlocks. Coarse non-iodized salt brine, at 2 to 3% concentration, initiates lactic acid fermentation in cut vegetables within 48 to 72 hours. The lactic acid produced drives pH below 4.6, the threshold below which Clostridium botulinum cannot produce toxin under any circumstances. This is not folk practice. It is the documented biochemistry behind commercial fermented food production on every continent. Prepare in silence. Full tray assembly and crock specifications are in the description. What this stack produces is a conversion of fresh caloric supply into shelf-stable caloric density, without a watt of external input. The final layer of this system is the one that makes everything else durable. Shade and thermal mass integration protocol. You have sealed your food, built your storage, hung your rig, and started your ferments. The remaining variable that degrades everything else you've built is thermal cycling, the daily swing between afternoon peak heat and pre-dawn cold. That swing is the degradation mechanism for Mylar seals, fermentation pH stability, and Zeer-Pot performance simultaneously. Deploy 70 to 80% ultraviolet rated shade cloth above and around your storage zone. That percentage is not aesthetic. It is the value at which solar thermal gain drops below the threshold, causing internal temperature to exceed 35 degrees Celsius during peak summer hours in temperate climates. Anchor the cloth with marine-grade clips and maintain a 10-centimeter air gap between cloth and the top of your storage structure. The gap drives convective airflow that prevents heat stacking. Position 3 to 5 2-liter water jugs inside the storage zone perimeter. Water has a specific heat capacity of 4.18 kilojoules per kilogram per degree Celsius, the highest of any common non-toxic ballast material available at zero cost. During daylight hours, the jugs absorb heat. After sunset, they release it. The result is a buffered thermal envelope that reduces daily temperature swing by 8 to 12 degrees Celsius compared to an unshielded outdoor setup. This is the same thermal inertia principle used to stabilize below-grade civil storage facilities brought to a balcony. Run a 2-week maintenance cycle. Inspect rope at the pulley contact point for abrasion. Rehydrate the sand layer in your Zeer-Pot. Check Mylar seals for micropunctures. Verify brine depth in fermentation crocks. 4 checks. 1 schedule. No power required. Stay invisible. This is not a preparation you make once. It is a system you maintain. The people who maintain it are the ones who don't have a problem when everyone around them does.